Hello, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Aika bin Ibrahim. Nombor metrik 13 DAD 21F1169. Hari ini saya ingin membentangkan tajuk internal combustion. Yang mana saya akan inti ni dia punya function, dia punya kegunaan dia untuk menukarkan daripada satu tenaga kepada tenaga, daripada apa-apa tenaga kepada tenaga mekanikal. Lepas tu dia punya proses dia adalah menggunakan natural process, yang mana bila dalam ruang pembakaran tu dia mempunyai pressure yang rendah. Jadi berbanding dengan pressure di luar enjin, mempunyai pressure yang lebih tinggi daripada tekanan yang lebih tinggi daripada dalam enjin. Jadi bila dalam enjin tu tiada udara, tiada oksigen, tekanan yang rendah, jadi udara daripada luar senang masuk ke dalam enjin. Okay. Jadi yang ketiga adalah dia penting untuk kegunaan transport, dan dia penting untuk kegunaan industri. Biasa ke jumpa dalam industri. Dan dia punya advantage daripada enjin tu dan advantage internal combustion tu kan, dia punya contoh, dia punya proses dia punya advantage dia adalah dia menyebabkan high temperature dan high pressure. Jadi benda yang kita nak sebenarnya terjadinya pembakaran di dalam chamber, di dalam ruang pembakaran. Jadi gitulah dia punya proses. Dan dia didesainkan, dia punya advantage design daripada enjin tersebut adalah dia fuel tu mudah terbakar. Dia punya advantage dia. Fuel dengan walaupun air di sini tukar kan, tapi sebabkan design dia macam enjin menggunakan uap air kan, dia membakar tempat tu sebab dah design dah macam tu untuk bakar tempat bakar tempat air tu untuk dapatkan tekanan yang tinggi. Jadi bila tekanan yang tinggi tu dia akan jadi letupan, tapi lambat menggunakan air. Jadi untuk pada zaman sekarang ni dia menggunakan fosil seperti minyak petrol, macam tu lah. Jadi dia macam tu lah cerita dia. Jadi pressure versus volume and pressure versus volume graph dia terbahagi kepada tiga, iaitu auto cycle, DC cycle dan dual cycle. Ni standard, dia tiga untuk standard cycle. Dia terbahagi kepada tiga. Jadi kita ni adalah contoh dia punya auto cycle, dia punya graph. DC cycle dia punya graph auto cycle dulu. Untuk next slide, kawan saya akan membentangkan Tapi untuk auto cycle ni saya akan membentangkan dan cuba menerangkan tentang auto cycle. Jadi auto cycle yang menggunakan sekarang ni adalah 4 lejang. Yang untuk lejang pertama ni adalah lejang exhaust. Dia bila piston tu akan tarik keluar, dia akan tarik keluar dan dia akan sambil tarik keluar tu dia akan masuk intake stroke. Dia akan masuk udara ke dalam chamber. Jadi bila dah masuk tu kompres stroke, dia akan kompres sampai ke pressure tinggi lah ni, nombor 2 ni. Dia akan kompres bila dah sampai nombor 2 ni, pressure dia tinggi dan terjadinya letupan. Bila terjadinya letupan, injection nombor 3 lah pergi. Dia pergi nombor 3 tu kan. Pergi nombor 3 tu, bila dah pergi nombor 3 tu, dia akan memberikan power. Dia bagi power, dia tendang dia lah panggil. Dia punya piston tu pun turun kan. Bila dah turun, dia akan jadi lejang lain lah kan. Bila dah jadi lejang lain tu, dia jadi sebagai nombor 4 ni lah. Bila dah masuk sini, ni lejang exhaust. Bila nak masuk nombor 1 ni lejang exhaust. Lepas tu bila dah nak pergi tu, dia intake pergi sini. Jadi ni lejang exhaust. Jadi bila nak masuk tu, dia akan buka untuk masuk balik. Jadi pusing-pusing gitu lah cerita dia.
Assalamualaikum, my name is Ani Akasha bin Muhammad Arif. My number matric is 13 DAD 21F1070. This I want to talk about diesel cycle. This is a diesel cycle diagram. As you can see, 1 to 2 isentropic compression, 2 to 3 constant pressure head addition, 3 to 4 isentropic expansion, and 4 to 1 constant volume head rejection. As you can see, the diesel cycle is a combustion process of a reciprocating internal combustion engine. In it, fuel is ignited by heat generated during the compression of air in the combustion chamber, into which fuel is then injected. This in contrast to igniting the fuel air mixture with a spark plug as in the Otto cycle, 4-stroke petrol engine. Diesel engine are used in aircraft, automobile, power generation, diesel electric, locomotive, and boat surface ship and submarine. Next, this is a dual cycle. As we can see, the dual combustion cycle, also known as the mixed cycle, Trinkler cycle, Ziegler cycle, or Sabatic cycle, is a thermal cycle that is a combination of the Otto cycle and the diesel cycle. First introduced by Russian-German engineer Gustav Trinkler, who never claimed to have developed the cycle himself. It is partly at constant volume isobaric and partly at constant pressure isobaric. The significance of which is that more time is available for the fuel to completely combust. Because of lagging characteristic of fuel cycle, invariably used for diesel and hotspot ignition engine. It consists of 2 adiabatic and 2 constant volume and 1 constant pressure process. Next, for specification engine. As we can see, this is a diesel engine with a 4-stroke. Intake, compression, power, exhaust. Diesel have a 3-part different. Number 1, compression is air is inducted into the chamber during the intake stroke and compressed during the compression stroke. Number 2, direct injection, with the fuel being injected into the air just before combustion. The dispersion of the fuel is uneven. This is called a heterogeneous air fuel mixture. And then number 3, diesel would require a much higher level of compression that need for compression ignition.
Assalamualaikum. My name is Muhammad Anas bin Muhammad Syafi'i. My metric number is 13DAD21F1126. Today I want to talk about the CNG engine, different of CNG engine. Here have 3 points. The first one is spark. A spark plug is an electrical device used in an internal combustion engine to produce a spark which ignites the air-fuel mixture in the combustion chamber. The second one is sequential inject. A sequential fuel injection is a type of multi-port fuel injection system in which each injection valve will open just before the cylinder intake valve open. So in essence, the individual injectors work by themselves because they are fired individually. For the third point is CNG. CNG engine use compressed natural gas to power. For the car, CNG is a substitute for gas and diesel fuel and is considered to be much cheaper and cleaner than gas or diesel. For my side is, I want to talk about crank angle versus cylinder pressure graph or diagram. I will explain the graph in the next slide. In this slide, I will explain the graph. In cylinder pressure versus crank angle degree, the curve shows the change of the crankshaft angle on the pressure chart in the chart result obtained in figure 4. Appear to be consistent with the chart result obtained in figure 3. It was pressure change throughout the cycle movement in the cylinder. The main reason for this change varies depending on the situation where the intake and exhaust valve are closed or one is open. According to the state where the pressure is highest in the cylinder, the state where it is lowest, 680 0 CA, 685 0 CA, 690 OCA, and 695 OCA. In the pressure crank angle graph, a knock core is formed in areas where the pressure is too steep. It was as a result of the fact that the ignition advance occurred on the pressure and temperature increased with the movement of the piston down the TDC. Knock occurs in the cylinder. It is during the formation of knock. An increase in pressure and temperature is observed in the cylinder with the progress of the flame. The impact core occurs when the temperature and pressure increase as a result of compressing the air-fuel mixture in the movement of the piston to the TDC. The maximum knock core is 8.8 MPa at 680 OCA. I will go to the next slide.
Discussion and conclusion. Ada 4 iaitu ignition timing, maximum pressure, flame propagation stage, dan conclusion. Ignition timing ada 4, iaitu pertama pivotal role. Pivotal role in determining engine performance by regulating the spark that ignite the fuel mixture within the combustion chamber. Yang kedua, excessively. Advancing the ignition timing excessively can lead to premature combustion, resulting in knocking and potential engine damage. Yang ketiga, too much. Retarding the ignition timing too much can cause delayed combustion, diminishing engine power and efficiency. Dan yang keempat, avoid fine tuning the ignition timing. Utilizing specialized equipment is crucial to discover the optimal setting for maximum power and efficiency. Seterusnya iaitu maximum pressure. The highest of cylinder pressure is around in crank angle or 0 degree TDCF. Direct injection diesel engine is higher than modified direct injection diesel engine and the port injection dedicated CNG engine, because the compression ratio of diesel engine is higher. Maximum pressure CNG 1500 rpm is at 70 bar, while the maximum pressure of diesel is 85 bar. Next, flame propagation stage. Explain the function. The flame propagation stage is an internal combustion engine. Mark the initiation of the air fuel mixture, initiating the propagation of the flame from access the combustion chamber. There be burning the mixture and releasing energy. The phase is crucial for achieving maximum power output and engine efficiency. Important. Precise control of this variable is essential to optimize engine performance and prevent issues such as engine knock or connection, which could lead to engine damage. In the case of CNG, the flame propagation stage begins at a crank angle of -10 with a cylinder pressure of 40, while for diesel it starts at a crank angle of -10 with a cylinder pressure of 50. Conclusion. Although diesel engine push higher cylinder pressure and greater power output, the transition to a port injection dedicated CNG engine present advantage including reduced emission and improved efficiency. And last, to optimize engine performance and efficiency, advanced control system and technique need to be employed, taking into account factor like spark timing, fuel ratio, engine speed and combustion chamber design. Sekian itu saja saya. Terima kasih.